sampling techniques. These techniques are employed in selection of samples. You know, in research, an investigator or a researcher wants to identify a particular finding in order to generalize it to the population. But most times, it becomes difficult to study, almost impossible to study the entire population. And this difficulty is what led to taking a subset of that population who have similar characteristics with the entire population to study, whilst generalizing the whole outcome on the entire population of interest. Now, it is the selection of this sample that would introduce error or bias. If at all the population is to be studied, fine. But where it becomes impossible, you are going to require a subset of the population for the research, and that is not a sample. So for you to do this, in order to reduce the chances of errors and bias, you will have to require sample and a sampling technique. So therefore, a sampling technique refers to the method used to select a subset of individuals or items from a larger population for the purpose of conducting research or gathering data. Sampling is crucial in research as it allows researchers to make inferences or conclusions about the entire population based on the characteristics of sample. Sampling techniques are crucial in research to ensure that sampling or sample chosen is representative of the population being studied. There are two main categories of sampling techniques: probability sampling and non-probability sampling. In probability sampling, every person in the population have equal chances of being selected into the sample, whereas in non-probability sampling, they do not have. But for this purpose of this lecture, we are going to focus on probability sampling techniques. Probability sampling techniques ensures that every member of the population has a known and non-zero chance of being selected, which leads to a more reliable result. First is random sampling. In this technique, each member of the population has an equal chance of being selected. This method is unbiased and ensures that every possible sample of a certain size has an equal chance of being selected. What are the procedures involved? First, identify the entire group of individuals or elements that you want to study. For example, if your research topic is on the prevalence of diabetes among adults in Obommiri, the population would be all adults living in Obommiri. That would be the entire population. Now, this entire population, you need to know their total number. It could be 10,000, it could be 15,000, it could be 2,000. So in simple random, you must know the total population. Then you have already determined your sample size. I think the size of the sample you want in your research. It could be 200, it could be 300, it could be 150. And this is done based on certain statistical formulas and desired confidence level. Then what's the next thing you would have to do? You will now assign a unique identifier or number to every member of that population. Let's say there are 500 adult women you are interested to study in Obommiri. You are going to give them number 1, number 2 until 500. This number or code will help in random selection process. Now, you randomly select samples or you randomly select individuals that will be in the samples, from that population you have numbered. This can be done by using random number generators or drawing lots. You can use a folded paper, write yes into 200 because your sample size is 200 as you have chosen. You now write yes and fold it, then write the remaining 300 no. Those persons who picked yes will be included. So you fold it and everyone who picks, those who picked yes will be in the sample, and they must be up to 200 because the yes you have written should be up to 200. Those who picked no will be excluded. In that way, bias is removed. Whoever that is picked is by probability, or whoever that is selected is by probability. Then the researcher would now collect data from that 200 who picked yes, using maybe surveys, medical tests, or interviews in order to gather relevant information from them for the studies, in order to answer his research questions and test his hypothesis. The next method is stratified sampling. Here, the population is divided into subgroups or strata based on certain characteristics, and then samples are randomly selected from each stratum. This method ensures representation from all subgroups. First of all, you will have to identify the relevant subgroups. Let's say you want to carry a research on the attitude of students towards mathematics in a university setting. You know, in university, there are faculties, there are departments. You cannot carry out a research and say, the attitude is poor, when everybody from each of the department are not included in the study. So therefore, each of the department will form a strata of its own. Strata. Psychology strata, medical strata, educational strata. From these stratas, you would then select individuals randomly. You will now employ simple random method to select individuals from each of these strata based on their population, until you be able to get your sample size. Let's say your sample size is 200. And maybe the department that are in that school is up to 50. You have to share it according to the strength of each of the department that will be included in that 200 sample for you to carry out the research. By the time you have to select from each of the stratas, you add in that your sample, you now administer questions or questionnaire, interview or survey, and collect your data. Another way could be maybe you want to carry out a study on a particular group, age group. Say, let's say from 10 years to 50 years. You will have to include every representative of all the ages. 5 years to 10 years extractor, 20 years to 30 years extractor, like that. Or gender or socioeconomic class based on a certain characteristics. But then you ensure equal representation from each of the stratum by selecting them randomly. So that is all about stratified sampling technique. The next is systematic sampling. Here, researchers select every night member from a list of the population. This method is simple and efficient, but requires random starting point. Systematic probability sampling is a method used in statistics to select random sample from a large population. First and foremost, you will have to clearly define the population you are studying. This could be a group of people, objects, or events that you want to draw conclusions about. You have to determine your sample size. Then once you have done that, you have to know the total number of persons or total number of elements in that population Let's say in the population of Ugbo, there are 5,000. You have to know those men of childbearing in how many years, how many are they in number? Let's say there are 3,000. You have to know. Then you are assigned a number to all of them, or arrange them in ascending order, or arrange them by any means, let's say by alphabetical order or by their surname. You arrange them until the last 3,000 person, or let's say there are 500 in number, from 1 to the last person, which is the number 500. You arrange them. Then you are going to determine your night or the sampling interval. How would you do that? The total number of persons in that woman of childbearing age is 500, and your sample you want 100. So by the time you divide the total population by the sample you want, you will get the interval. And here is 500. You divide it by 100, your sample interval will be 5. But the example we gave here, the total population is 1,000 and the sample is 100. So by the time you divide 1,000 by 100, it gives you 10. So the 10 is the what? The interval. Once you have determined the interval, you now randomly select from that list of 1 to 1,000 persons, maybe using random number generator, or by folding. Maybe you fold from 1 to 1,000 and you picked number 100. Every other persons from 99 upwards are no longer involved in the selection process. But from that 100 downward will be involved. So by the time you pick 100, then the person that his number is number 100 will be selected into the sample. Then you count the next 10 person. You count 100. 100 have been selected. 101, 102, 103, 104, 105, 106, 107, 108, 109, 110. The 110th person will be added because the 10th interval. Then the next 10th interval, which is 120, will also be included in the sample. 30 will be included, 40 will be included, 50 will be included until the sample size of 100 will be completed. Then you administer your questionnaire and collect data. Take for example, let's say you are studying a population of students in university, and the population consists of all undergraduate students enrolled in the university. You have decided the sample size you want to be 200 using statistical formulas and based on your confidence interval. You have to establish the sampling interval. And the sampling interval is calculated by dividing the total number of students in the population by the sample size. If the total number of students in the university is 2,000 and the sample size is 200, if you divide 2,000 by 200, it gives you 10. Now, start the systematic sampling process. You will have to randomly select a starting point within the population. You can use a random number generator. And let's say the student selected 57 as the starting point. Now, 57 will be included in the sample. Then any other 10th person, if you count until the next 10th person, and if you add 10 to 57, the number 67 is the next, and you include it. You add another 10 to 67, give you 77. That's the next person you include until you reach the sample size of 200. That is the systematic sampling. Then cluster sampling. In a cluster sample, population is divided into clusters. These clusters are randomly selected for sampling. This method is useful when the population is geographically dispersed. Cluster probability sampling is a method used in statistical research to select a sample from a population. In this procedure, the population is divided into clusters or groups, and then a random selection of clusters is made. Within the selected clusters, all individuals or elements are included in the sample. Within the selected clusters. All individuals or elements are included in a sample. Cluster probability sampling is particularly useful when the population is large and geographically dispersed and can be more cost-effective and practical compared to other sampling methods, especially when it's difficult to obtain a complete list of the population. You know, the ones we explained earlier, you will have to get the total number, like the random, simple random. You are going to get the total number. But in cluster, you don't need it. And where the population becomes difficult for you to get, use cluster sampling. Here, first of all, you divide the population into clusters or groups. These clusters should ideally be heterogeneous within themselves, but homogeneous between clusters. Let's say you come to a community, Ubomiri, and you want to use a cluster method. In cluster A, Umabaka, and that Umabaka must be made up of male, female, children. And let's say you want to carry a research on the utilization of primary healthcare facilities, and you are using cluster. In cluster A, Umabaka, inside that Umabaka, they are going to be heterogeneous because they are male, they are female, they are children, they are old people. All these people make use of health facilities, which makes it that they are heterogeneous. Then in cluster B is Umoma. Cluster B is Umoma. Inside Umoma, they are male, they are female, they are children, they are old people, making them also heterogeneous. In cluster C, Ndiuba. In that Ndiuba, they are male, they are female, they are children too, making them heterogeneous. But now, among cluster A, cluster B, cluster C, they are homogeneous in the sense that what you find in cluster A, male, female, children, and old, is also what you find in cluster B, male, female, old, and children. The same thing in cluster C. So that is what we're trying to explain. They are going to be heterogeneous within themselves, but they are homogeneous between clusters. So since they are heterogeneous and they are homogeneous, you are going to select randomly, you select a particular cluster. And when you select that particular cluster, you use it for your sample and study everyone that is in that sample. Then you identify your questionnaire or survey and collect your data. The next is multi-stage sampling, probability sampling. This sampling is a complex sampling technique commonly used in public health research to obtain a representative sample of a population. This method involves multi-stage, according to the name, where smaller and more manageable groups are selected at each stage. It is particularly useful when a complete list of the entire population is not available or when the population is geographically dispersed. Let's illustrate using an example in public health. Let's say you want to study health behaviors in a city. Imagine a researcher wants to study health behaviors in a large city with diverse neighborhoods. The population consists of various districts, and it is not feasible to create a comprehensive list of all residents. At first stage, known as primary sampling units, you are going to divide the city into districts, considering geographical and demographic characteristics. Now, when you have divided it into districts and geographical or demographic characteristics, you randomly select a certain number of districts as primary sampling units. For instance, you select 5 out of 20 districts in the city. That's at first stage. Then at second stage, known as secondary sampling units, within each selected district, you identify secondary sampling units, which could be neighborhoods or blocks. Randomly select a certain number of secondary sampling units within each chosen district. For example, you select 3 neighborhoods from each of the 5 chosen districts. You move to the next stage, tertiary sampling units. Within each selected neighborhood at the secondary level, you identify tertiary sampling units, which could be household or individuals. you randomly select a certain number of tertiary sampling units within each chosen neighborhood. For instance, randomly select 10 households from each of the 3 chosen neighborhoods. From the selected neighborhoods or households, individuals, you gather your data for the studies on health behavior. So that is the method of multi-stage. Another example is, let's say you want to study the utilization of vaccines among under 5 children in Nigeria. You cannot get the list of people in Nigeria. So first of all, you do a random selection, that is randomization, maybe simple random. You write number 1, South is number 2, South number 3, until you get the 6 geopolitical zone in Nigeria. And then you ballot and selected, and luckily you got 1, which is Southeast. Now you are going to select Southeast. That's the first stage. When you enter Southeast, there are 5 states. You do another balloting again, and you selected Ebonyi State. You move down to Ebonyi State. Get the 3rd stage. Inside Ebonyi State, there are local governments. But what you require is a particular community in that local government. You do another random selection again, and you identify Ikko as the local government of interest. Then when you get to Ikko, you can use any other sampling technique now, maybe systematic. Then you select a particular community. Then you now use that community to do your studies. You see, stage by stage, hence the name multi-stage sampling technique.